Hey guys, in our first video, we defined this word expression, and I promised to give you a little more detail about each of the component words there. Right, so expression is a meaningful collection of a few things here. A collection of numbers, variables, operations, and or grouping symbols. So let's look at each of these in turn. So a number, right? We kind of know what numbers are. Right? In our typical place value decimal system that most of us are used to, um, we have one-digit numbers and two-digit numbers and so on. We have other numbering systems. You might recognize Roman numerals here. Different civilizations throughout history have had different ways of representing numbers, but whether we write our number using a big capital X or a 1 and a 0, or the letters T-E-N, we're still referring to the same collection of objects, whether we put it as a big blob or a more orderly way that's easier to count. We're still talking about this number 10, right? So a number just means a particular amount or quantity. So quantity, usually we're talking about a discrete number, a counting number, something like 3 or 4, right? We're counting dots here. But a number could be something like 2/3 or 3.479, right? Or the number pi. Pi does have a particular amount. But you can't have pies, right? You can have 3 pies. With the little pretty things on there, like my mother-in-law makes on her pies. But you can't have this many exact pies. So we've got counting numbers and we've got measuring numbers, but they're all talking about this. All right, next, variables. Well, variables, my definition might be slightly different than what you're used to, but a variable is a symbol. Say A, I should use singular. A symbol that represents an unknown, or, and this is what makes my definition maybe a little unique, or undisclosed amount. Right? Variable doesn't just mean that it's unknown. Sometimes it's intentionally unknown, sometimes it's intentionally left out. Sometimes we're stating some general rule. It's not that we don't know the length and the width. It's that in general, without specifying the length and the width, we can still specify this relationship. Right? Another definition for variable is something that varies, right? That's where we get the word from. And that differentiates it from something like pi, where I'm not talking about some days pi is 3.14 and other days pi is something else. Some days pi is 3.1415926535897993. It's about as far as I can go off the top of my head. Right? That's not a variable. It's always that precise amount. Sometimes we round it off at different places. Whereas in this situation, the area of a rectangle is dependent on the values of these two, right? But we still have the operations in here like we would have with numbers. All right, now to operations. That's kind of the key of all of algebra. So this is a really important definition here. An operation is a procedure. I always get my which and that mixed up. Procedure that produces a new output value from one or more input values. I'm going to put that new in parentheses because it's not always new, right? But the idea is we have input values and an output value. So if we get an example here, 3 times 5. Here are my input values. Three times 5 is 15. That's my output value. And I know that this will be the output because I know what this symbol means. I know that 3 times 5 means 5 plus another 5 plus another 5. And we'll get into more detail about multiplication and addition in a little while. But knowing our definition of this operation tells us what's going on here. If I just have a 3 and a 5 next to each other, that's not the same as 15. That's the same as 3 tens and 5 ones. Right? 30 and 5. That's what a 2-digit number means. But if I have 3x, that does mean, not times, x plus x plus x. Right? So in our symbolic rules here for what symbols mean what, we've decided that when we have a number next to a variable, we don't have to put the multiplication symbol. But if we have two numbers next to each other, we do have to put the multiplication symbol. 3 times x means the same thing. So we would call this the simplified version of the same expression. And so every operation has its own symbol. And recognizing what operations are being used in our problem and the relationships between those operations, that's going to be our key to making sense of all of our expressions and equations this semester and moving forward. So let's get into a little bit more here. And let's create some models, right? We said mathematicians create models of unfamiliar real-world situations. So let's start with something really basic, something like 3 more than a number. All right, so we can recognize more than, I've got some number, and I have 3 more than that, as opposed to something like this. Where that is completely changes what's going on here. I now have a full sentence. I can put a period at the end of this. Right? 7 is 3 more than a number. I've got some number. 3 more than that is going to be the same as 7. So we could probably guess this will be true this statement will be true if n is equal to what number? 4, of course. Right? 3 more than 4 is 7. So a statement here, this equation, a statement that two expressions have the same value, right? That's our definition of equation. That's either true or false depending on the value of my variable here. I have another very similar looking statement here. I fix my typos. What's missing from this version? There's no 3. I'm just saying 7 is more than a number. It's some amount more than a number. If I'm looking at my number line, here's n. If I add something to it, I'm going to get to 7. But I don't know how much more I need to add. That's what makes this not an equation, but an inequality. All I know is 7 is somewhere to the right on the number line compared to n. So there's my inequality symbol. 7 is more than that number. And we'll get to inequalities and solving complicated inequalities later this semester. But it's important that we understand the syntax of how we translate into English. Is more than altogether is kind of like our verb. That's this statement here. Is, not is more than, but just plain is, there's our equal sign. 3 more than a number, there's our expression. All this together, 3 more than goes with that. Let's actually change the color to make that a little more clear. Three more than whatever we started with. Now with addition, n plus 3, 3 plus n means the same thing, right? 3 plus 4, 4 plus 3, addition's commutative. We're fine with that. But we want to be careful in our translation because not every operation is commutative. So if we have something like 3 less than a number, well, if I have n minus 3 or 3 minus n, those are not the same. 7 minus 3 is not the same as 3 minus 7. So we want to think about context here. Right? Application is not complicating things, it's giving us a context to understand things. If I have $100 and my buddy has 3 less than me, I'm not doing 3 minus 100 to say he's got negative $97. It's an ugly 9. I'm saying 100 minus 3 to get $97, right? 3 less than whatever I'm starting with. So we do have to be careful with that phrasing. Now we want to be able to look at more complicated ones as well. Say something like 2 less than the product of 8 and a number. All right, here's my 2 less than. Let me go for blue here. 2 less than something, 2 less than a product. I need to know what product means. Product means I'm multiplying. Right, so I do the product of whatever it's saying, then 2 less than that to get my answer. 2 less than the product of these two things, of 8 and a number. So I can make that a little bit nicer. There we go.